So oxygen's ATA 35. It's also covered, servicing is covered in ATA 12. And there's crew, passenger, and portable is what we're basically broken down into. Oxygen systems, here's the servicing cart, big one, requirements. It is, you're going to use aviators breathing oxygen. It's stored in these pressurized cylinders. They start somewhere around 2,000 to 2,500 PSI. Just be careful with them. And they're delivered, the oxygen, we'll talk about how it's delivered, and then maintenance real quick. So why do we have oxygen? We have to maintain a cabin altitude below 10,000 feet. If we can't, or if it fails, then we have to have supplemental oxygen available for both crew and passengers to keep people from being hurt by lack of oxygen. Okay? So it can be stored gas, chemical, or liquid. We're not going to really talk about liquid oxygen. Liquid oxygen is more of a military thing, but we have stored gas and chemical on just about every transport aircraft out there. So in a typical gaseous system, we're going to have our cylinder. We have to regulate pressure. Cylinder's high pressure. We got to regulate it down to usable pressures. We want to know if there's pressure. Oxygen's got to travel through lines to outlets, masks, and then we have to be able to service the system. So aviators breathing oxygen, you can have two different types of bottles. Most transport aircraft nowadays use green high pressure bottles, which range anywhere from 18 to 2,200 PSI, and that'll obviously change a little bit with temperature as well. The warmer it is, the higher the pressure in the bottle, the colder is that. There's different hydrostatic test years required and service lives, but for the most part, you'll see pretty much .3AA or .3HT with occasionally some of these composite or aluminum bottles, but really they are very expensive, and so most places have the steel bottles with unlimited service life. They're the cheapest to maintain. They really don't weigh that much more. We have to regulate it down from that 1,800 PSI to something you can breathe. We also have different types, continuous versus demand. And that is continuous is oxygen is always flowing to the mask. Demand is it only floats when you breathe in. The low pressure in the mask causes a valve to pop open. That's when it delivers oxygen. And it makes more efficient use of the oxygen you have rather than, if you're sending oxygen when you're breathing out, you're just wasting the oxygen. So those can be, you'll have things like rebreather, diluter demand, pressure demand, or combination. Rebreather is these little bag ones you see here. You breathe out, bag may not inflate. It mixes some oxygen into the air you breathe out, and then you breathe that back in again. As long as you're mixing oxygen into it, you're going to be fine. You're not going to suffocate yourself. Diluter demand takes some outside air, mixes oxygen in it. That's typically if there's not enough pressure. There's not enough pressure. We got to saturate the air with more oxygen. Pressure demand is it's got a positive pressure, and that's usually used by crew masks in a situation where there is smoke or chemical where you don't want to be mixing in the outside air as you're breathing in. And so they're under positive pressure to force any gas, any outside air or smoke out of the mask. But again, they only work when you breathe in, when it starts to create that low pressure. I've got a video on a quick donning. I'll show that at the end if people want to see it. But I talked about continuous versus demand. So continuous flow can be light GA. It's also our rubber jungle that comes down. Okay, they're chemical oxygen generators that once they're activated, they continuously supply oxygen. They're mixing a little bit into your air every time you breathe, and they're really just to keep you from passing out if the cabin loses pressure. Gaseous systems have to have some kind of a distribution system where you have a bottle that's regulated going to various outlets that the masks hook up to, and this is what the crew, the flight crew would use. So here's a chemical generator. This is a passenger service unit, the overhead panel. This is what it looks like on the outside. Here's what it looks like on the inside. And specifically, here's our oxygen right here. Here's the oxygen generator, feeds various masks that are stored in a box. This is the looking from above. It's inside this panel right here. You also have lights and speakers and gaspers and that kind of thing. So there's our speaker, our chemical generator, our masks, air vents, and reading lights. Chemical oxygen generators, they have a sodium chlorate candle. When it's ignited, one of the byproducts of combustion is oxygen, and that's what's given off. They also deliver a high amount of heat. When these would go off in our airplanes, by the time they would get to the ground after all the passengers had activated them, it would be about 120 to 130 degrees in the cabin because they got so hot. Okay. Masks can deploy automatically. There's pressure sensors that can trip them, or manually from the cockpit. When they tell you to pull on the mask, that's what activates this firing pin and begins the flow of oxygen because the sodium chlorate candle begins to burn. Demand system. This is the masks that are up in the cockpit. Diluter, pure O2 in atmosphere, pressure is pure O2. And I talked about using pressure mode for when there's smoke or chemical fume clearing. The regulator itself on the mask is what determines what type it is. Most crew masks you can switch between modes. So if it's just they've lost pressure, they want the gas to last as long as possible, they put it into a diluter demand scenario where it's adding oxygen to the air they're breathing. If they have smoke or chemical, in the cockpit, they flip it to a pressure system, and that will push it out. And even some of the masks have a goggle included with it. It will pressurize that and blow any smoke out of there so they're not getting smoke in their eyes and help them to see. Not to mention you'll open outflow valves and that kind of thing to suck smoke out. So those are kind of the two main systems and generally how they go together: bottle, regulators, filters, and then that. So those each have their own regulator. There is no regulator on the continuous flow chemical generator type. Okay. Let's skip ahead because I'm kind of covering. Portable oxygen, we got bottles. These are continuous flow, cabin crew, loss of pressurization, or they can be used for medical emergencies if you need to give somebody oxygen in the airplane. Oops, go. Service, 1,800 to 2,000 PSI. After you work on it, you got to purge it, run some oxygen through, get any non-oxygen out, and finally perform a leak check. Here's charging pressures based on temperature. Purging I was talking about, leak check, put some soapy water on it, look for bubbles. All connections within the system, you got to make sure aren't leaking because that oxygen can turn into a little blowtorch. It's 11:50, I made it. Questions on that?